AP Style Free Response Problem 2. Consider the following data concerning the equation H2O2 plus 3I minus plus 2H plus produces I3 minus plus 2H2O. A, what is the rate law for this reaction? And B, what is the average value for the rate constant K with units? And we're given a table of experimental data where we can determine the rate law with respect to each of these reactants, H2O, I minus, and H plus. So take a look here. There are times where we're holding one of them constant, but changing the others, okay? So we can write the rate law and then find the rate constant. All right, so let's do some comparisons here. You can always set up those mathematical proportions that we've shown before, but I think we can see this pretty straightforward. So if we compare experiment 1 and experiment 2, in that case, we're holding H2O2 constant and H plus constant. So we're seeing what is the impact on I2. So the difference from here to here, okay, the change there is 2. Okay, so this is double. If I take 5 times 10 to the minus 4th and multiply it by 2, I get 1 times 10 to the minus 3rd. So this is times 2. Okay, and then what happens from here to here? This is also times 2. 0.137 times 2 is 0.268. Okay, so what that means is the reaction is first order with respect to I minus. Okay, first order with respect to I minus. Now, let's compare the next two. Comparing 2 and 3. So what are we holding constant now? I minus and H plus. What happens as we go from here to here for the H2O2? We're doubling, right? We're doubling. And so the same is true from here to here. We're doubling. Okay? So also first order with respect to H2. And now finally, comparing 3 and 4, the reaction is 0 order with respect to H plus. So take a look at here. If we compare 3 and 4, I minus is staying the same. H2O2 is doubling, which we know means this will double, and it does. But at that time, we also doubled the H plus concentration, which means the reaction is 0 order with respect to H plus. Then the rate law will just be rate is equal to K times the concentration of H2O2 to the first power times the concentration of I minus to the first power. And then of course we don't include the H plus because it's 0 order. And overall, the reaction is second order. All right, in part B, we're asked to find the average value for the rate constant K with units. So to find the rate constant, we just substitute the data from any of the experiments in the rate law to solve for K. In this case, we used the data from experiment 1. So 0.137 molarity per second for the R, the rate, and then 0.1 for the concentration of H2O2, and 5 times 10 to the minus 4th for the concentration of the I minus. We get a value of K equal to 2.74 times 10 to the 3rd molarity to the minus 1 seconds to the minus 1, or 1 over molarity seconds.